Welcome, developers and AI architects. Today, we are exploring the cornerstone of context engineering in Claude Code, the Claude.md architecture file. We will learn how to create a source of truth that tells your AI exactly how to build, test, and scale your specific project. Let's get started. Let's kick things off by defining what Claude.md actually is. What is it? It's a persistent markdown file that serves as the central nervous system for your AI assistant. The basics are incredibly straightforward. When you start a Claude Code session, this file is automatically ingested into the context window. Why is this so critical? Because without it, Claude is forced to guess. It might use NPM when your team strictly uses PNPM, or it might implement class-based components when your architecture demands functional React hooks. How do you implement it? You just drop a Claude.md file into your project root. Taking a deep dive, you should treat this file exactly like an onboarding manual for a new senior developer. You aren't teaching Claude how to code, you are teaching it how to code for your specific project. Take a look at this flowchart, which illustrates the profound impact of having a Claude.md file. On the left, if the file is missing, the AI is forced to guess your project rules, leading down the red path to inconsistent outputs and hallucinations. On the right, the green path shows what happens when the file is present. Claude loads the file into its context window, aligns perfectly with your specific tech stack, and consistently outputs deterministic, high-quality code. To truly master context engineering, you must understand the memory hierarchy. What is this? It's the system Claude uses to read files from different levels of your directory tree and merge them together. The basics involve 4 main scopes: managed for organizations, user for your global personal habits, project for team-shared rules, and local for your private sandbox. Why do we need this complexity? Because it elegantly balances enterprise security with developer experience. Your IT team can enforce data handling policies globally, while you keep your favorite bash aliases in your user profile. How do you use it? You place files in specific locations, like /.claude/claude.md for global rules. In our deep dive, it's crucial to note that managed policies configured by system administrators are absolute and cannot be overridden by lower-level project files, ensuring strict regulatory compliance. This top-down diagram visualizes the cascading memory scopes. At the very top, we have the managed policy for organization-wide mandates. Below that is user memory, which captures your personal developer habits. This flows down into the green box, the project memory, representing the shared truth committed to your team's Git repo. Finally, at the bottom is the local memory, your private, Git-ignored sandbox for local overrides. Writing rules from scratch is tedious, which is why we have the /init command. What does it do? It bootstraps your context by deploying a subagent to scan your entire repository and generate a baseline Claude.md. The basics are simple. The AI reads your dependency files, like package.json or requirements.txt, and figures out your stack. Why is this a lifesaver? Imagine dropping into a massive, undocumented legacy codebase. Instead of spending hours figuring out the build pipeline, you run this command and Claude maps it for you. How do you do it? Just type /init. But here is the deep dive secret. If you run it with the environment variable Claude Code new init equals 1, you trigger an advanced, interactive flow. Claude will actually interview you about your preferences, testing strategies, and CI/CD targets, drafting a perfectly customized architectural source of truth. Let's trace the execution of the /init command in this sequence diagram. The developer runs the command, prompting Claude Code to scan the file system for dependencies and architectural patterns. The file system returns the raw data. If in interactive mode, Claude asks the developer clarifying questions. Once the developer answers, Claude synthesizes the information, writes the finalized Claude.md file to disk, and reports success. Having a Claude.md is great, but writing it correctly is an art form. What are we discussing here? The strategic formatting of your instructions. The basics dictate that you must use clear markdown headers and concise bullet points, and absolutely keep the file under 200 lines. Why? Because context is a finite resource. If you bloat your file with massive paragraphs, the LLM suffers from instruction blindness and will simply ignore your rules. How do you fix this? You must use explicit heuristics. Don't write vague platitudes like "write clean code that means nothing to a machine." Write exactly what you want. Always use functional React components with strict TypeScript interfaces. In our deep dive, remember that this file is treated as a system-level constraint. You must audit it like you would production code. Prune outdated libraries and resolve conflicting instructions immediately. This mind map breaks down the 4 pillars of a perfect Claude.md file. First is format, use headers, bullet points, and enforce the 200-line limit. Next is content, explicitly state your build commands, testing frameworks, and prohibited libraries. Third is tone, use explicit heuristics, zero vague platitudes. Finally, maintenance reminds us to treat this like code, audit it regularly, and aggressively prune outdated rules. As your project scales, you will inevitably hit the 200-line limit. This brings us to modularizing with dynamic imports. What is this? It's a feature that allows you to link external Markdown files directly into your primary Claude.md. The basics are simple. You just use the @ symbol followed by a file path. Why is this so powerful? Because dumping a massive API specification into your root file will degrade AI performance and bloat your tokens. How do you do it? You simply type it ./docs/API-standards.md in your main file, and Claude seamlessly pulls that data into its memory. Our deep dive reveals that these imports are highly sophisticated. They support recursive loading up to 5 levels deep, and relative paths always resolve based on the file making the call. This allows you to construct a modular, organized knowledge graph for your AI. Here we see a modular import architecture. The root Claude.md stays clean and lightweight by dynamically importing UI.md for front-end rules and db.md for back-end rules. Notice how UI.md further imports design-system.md. This recursive branching allows Claude to load a massive amount of highly organized context while keeping the root configuration file perfectly readable for human developers. To achieve maximum token efficiency, we use path-specific rules. What are these? They are specialized instruction files that only activate when Claude interacts with specific parts of your codebase. The basics involve placing Markdown files in the .claude/rules/directory and defining target paths using YAML frontmatter. Why is this necessary? Because loading heavy SQL database instructions while Claude is trying to fix a CSS animation is a massive waste of tokens and dilutes the model's focus. How do we implement this? You create a file, say frontend.md, and add paths, src/components //.tsx to the top. In our deep dive, we call this mechanism lazy loading. These rules lay dormant at the start of your session. But the exact millisecond Claude uses its read or edit tool on a React component, those front-end rules are dynamically injected, providing hyper-relevant context instantly. This state diagram maps the lazy loading sequence. We start in an idle session. If Claude decides to open server.py, the path matches our backend triggers, immediately pulling the backend rules into the updated context. Conversely, opening a button.tsx file routes through the frontend trigger, exclusively loading the frontend rules. The AI only holds the exact context it needs for the file it is currently touching. Let's see this in a real-time, high-stakes use case, the enterprise monorepo migration. Imagine your company is migrating from an old REST API to a modern GraphQL architecture. The trap here is that Claude's training data, and even the existing files in your repo, will heavily bias it toward using the old REST patterns. How do we fix this? Execution. The lead engineer edits the root Claude.md and explicitly writes, all new data fetching must use Apollo GraphQL. Never use REST endpoints. The outcome is magical. When a junior developer prompts Claude to build a user profile component, Claude reads the architecture rule, completely ignores the thousands of legacy REST files surrounding it, and autonomously writes a flawless GraphQL implementation. The value is immense. Your Claude.md acts as an unbreakable guardrail, forcing the AI to code for the future architecture, rather than repeating the technical debt of the past. Follow the sequence of our migration scenario. The developer prompts Claude to build a component. Crucially, Claude first reads the strict GraphQL rule from Claude.md. It then observes the legacy codebase, seeing the old REST files. Because Claude.md is the ultimate source of truth, Claude's internal logic overrides the legacy patterns and successfully delivers the modern GraphQL component back to the developer. To wrap up, we must discuss auditing and auto-memory. What does this entail? It means aggressively maintaining the health of your context window. The basics. Remember that Claude.md is manually written by you, but Claude also maintains an autonomous file called memory.md where it saves its own learnings. Why must we audit? Because over time, both files can accumulate conflicting statements, outdated hacks, and token bloat, a phenomenon known as context rot. How do we prevent this? Treat your context files like production code. Run the /memory command weekly to review and prune Claude's autonomous notes. In conclusion, mastering the Claude.md architecture file is what elevates you from a simple AI user into a true AI orchestrator. You are defining the cognitive boundaries of your digital team. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Thank you for watching. Our final mind map synthesizes your path to context mastery. On the left, we have the manual, Get Committed Claude.md for your team standards. On the right, the autonomous memory.md for personal quirks, which must be audited regularly. Below, we leverage architecture techniques like path scoping and dynamic imports. And the ultimate key to your success, visiting quicktechie.com to unlock your full potential with professional training and certifications.